All right, so here's an example where we need to prove that this equals this over here, secant to the fourth theta. And so what you want to notice here is that you have a common factor in the two separate terms. So here's one term, here's another term, and we have a secant squared that we can remove as a common factor. So for this one, you remove that secant squared theta. Again, just do an indicated operation or factoring or use an identity. Whatever pops out at you, you can just start wherever and start just simplifying, manipulating this side. And so we end up here with tan squared theta, and then plus what? Secant squared divided by secant squared is 1. Okay. So at this point here, you can write secant squared, if you want, as 1 over cosine squared. You can write tan as sine squared over cos squared. You can multiply some stuff in, but we just factored. So you don't really, probably maybe multiplying in wouldn't be a good idea. What you might notice here right now is that this is what? That is an identity, isn't it? That's a form of an identity over here. Tan squared, right? So it says tan squared plus 1. So does that, look at that. That's exactly this right here. 1 plus tan squared, same as tan squared plus 1. So what does that actually equal? It equals secant squared. So we've got secant squared theta times, this is secant squared theta. And of course at this point you look over to the side here and you're not very far away from this. You just perform this indicated operation and you have secant to the fourth theta. And you have proven that the left side does in fact equal the right side. Okay, any questions on that?